continue our discussion of workload adaptation, it's time to discuss patterns of skeletal robusticity variation. So to start, we're going to talk about the gracilization trend. So since the time of Homo erectus, there has been a general trend that indicates a gradual reduction in skeletal robusticity. Early human populations were more robust than contemporary populations. Now, if we look at the agricultural impact, the observed gracilization trend indicates that with the adoption of agriculture, populations experience a decrease in skeletal robusticity. The implication is that agriculturists were engaged in more sedentary behaviors that involved less physical work than was required under a foraging lifestyle. Now, if we look at prehistoric Georgia Native American populations, we have an investigation by Ruff and Larson in 1990 that examines skeletal robusticity changes that accompanied the shift from foraging and fishing subsistence strategies to one of maize agriculture. It was found that the external long bone dimensions of both males and females declined with the adoption of agriculture. This example provided further evidence to support the gracilization trend. Now, if we look at studies of prehistoric Alabama and Illinois' Native American populations, there's a pair of studies by Bridges in 1989 and Bridges et al. In 2000 that examined femoral and humeral changes in size and shape among prehistoric populations from the Alabama and Illinois. Intensification of maize agriculture resulted in an increase in femoral and humeral robusticity. In this instance, intensification resulted in greater physical activity. So this illustrates that subsistence strategy does not necessarily predict skeletal robusticity, as responses to subsistence changes are in fact phenotypically variable and dependent on local contexts. Ultimately, it shows that the gracilization trend is not sufficient to explain the adaptive history of skeletal robusticity trends. Now, if we look at industrialization, a similar logic has been applied to industrial societies. That gracilization trend is readily apparent when comparing our modern post-industrial populations to contemporary and historical agricultural populations. Again, the prediction is that with the adoption of an industrial subsistence strategy, there was a decrease in skeletal robusticity. Now, a 2015 study by Anne McGinnis and myself showed that early industrial laborers exhibited greater skeletal robusticity when compared to modern industrialists. The implication is that during early industrialization, laborers from the lower class were experiencing increased and more demanding levels of physical activity. So this once more demonstrates the variable nature of the phenotypic response to mechanical environments and the need to reevaluate the utility of the gracilization trend. This brings us to the question of race. Though not directly tested, this study also demonstrated the utility of using race to investigate variation in human body size and shape. Underlying American culture, there is an unspoken understanding that African Americans are more robust than European Americans, and this is linked to the old idea that Africans are less evolved and more primitive than Europeans. Now, statistical analyses showed that there were no significant differences between the two groups. This indicates that race is not informative on understanding variation in human body size and shape, and differences were the result of differential activity levels derived from economic status and occupation.